Good afternoon, we're Group 13, and today we're going to be presenting the paper Neural Correlates of Rumination in Depression by Rebecca Cooney and colleagues. This is an overview of our presentation. My name is Daniel Espinosa and I will be introducing the paper to you. Now, to begin, I invite you to consider the following statement. Think about what other people notice about your personality. Are your thoughts positive or negative? Research suggests that depressed people are more likely to respond negatively to this sort of statement, to think, for instance, they see me as boring and conventional, as opposed to focused and disciplined, leading to significant increases in negative mood and cognitive biases. Basically, the more depressed you are, the more likely you are to process stimuli negatively and to recall negative memories, which in turn serves to perpetuate your depression. This heightened attention to negative information, as well as a better memory for the negative than the positive, are some of the key processes of rumination. Put simply, rumination is a pattern of recursive thinking focused on one's negative mood. When you go through a particular issue over and over, without generating new or helpful ways to handle it, you're ruminating. Examinations of ruminative thoughts suggest that they are past-oriented and revolve around unresolved goals associated with the self. This process is hypothesized to be a vulnerability factor in developing and maintaining depressive episodes. In fact, rumination has been shown to prolong and deepen depressive episodes as well as increase the risk of relapse. Given this consistent association between rumination and depression, it is essential to examine the mechanism that underlies it. Rumination is likely to involve a broad range of cognitive and affective processes associated with activation in different brain regions, such as attention, self-referential processing, and recall of autobiographical memory. In fact, cognitive theories suggest that depressed people differ from non-depressed individuals precisely in these processes. Recent studies have demonstrated increased responsiveness in the amygdala for depressed individuals attending to negative emotional material. The amygdala and associated limbic regions have also been found to play a role in the sustained processing of this material. In other studies, self-reported rumination scores were correlated with increased and sustained amygdala activation for negative words in depressed individuals. This increased activation has also been shown to be associated with self-reported rumination in healthy individuals, suggesting that a tendency to ruminate can exacerbate neural processing of negative information in them as well. The relation between amygdala responsiveness and emotional activation, therefore, appears to be a main component of the neural network underlying rumination. Other brain regions likely to be involved in rumination are those found to be related to representations of the self. In addition to limbic structures, researchers have identified the medial prefrontal cortex, MPFC, as active in self-referential processing, self-reflection, and appraisals of the self-relevance of stimuli. This processing is also important in autobiographical memory, previously found to activate a network of regions, including the MPFC, frontal cortex, posterior cingulate, hippocampus, and parahippocampus. This regulation of the MPFC and nearby structures has also been hypothesized to play a role in the development and recurrence of depression. Thus, an involvement of the MPFC mediating autobiographical and self-referential content, along with hyperactivity in the limbic structures, may be a key contributor to rumination in depressed individuals. Now, the purpose of this study is to identify and elucidate differences between clinically depressed individuals and those without a history of the disorder in patterns of neural activation and self-reported mood ratings associated with ruminative thought. To serve this purpose, the researchers designed the rumination induction task with written statements resembling the one presented in the beginning. These statements have been used successfully in previous studies to induce a ruminative state in individuals with depression. However, they are not inherently negative or positive, and research has shown that they have no significant effect on control individuals. In participants with depression, on the other hand, increases in negative mood and enhanced cognitive biases were reported. We now turn to the hypothesis. The authors hypothesized that while thinking about these statements, participants with major depressive disorder and non-depressed control participants would generate different types of representations, memories, or self-related thoughts with different patterns of neural activation. Based on previous studies, it was expected that depressed individuals would exhibit greater activation in limbic regions, such as the amygdala, insula, and parahippocampus, the rostral anterior cingulate gyrus, RACC, and MPFC during ruminative thought.
Hello everyone, I'm Antong. I'll be discussing the method. So let's start with the demographic information for the participants according to Table 1. 28 participants took part in this study, 14 of which were from those in the MDD group, and the other 14 were healthy individuals which made up the control group. For the experiment group with MDD, in terms of sex ratio, 6 were males and 8 were females. In the control group, 5 were males and 9 were females. In terms of selecting the participants, the first step was that a structured clinical interview for the DSM-4 was used to diagnose both individuals in terms of the MDD participants and the healthy individuals that made up the control group participants. Secondly, the participants had to complete the Beck Depression Inventory, or what we call BDI-2, and a Ruminative Response Styles Questionnaire. Then the participants for the control group, they were those that were free of any lifetime diagnosis on an Axis 1 disorder, and they scored less than 10 on the BDI. For the participants with MDD, they were excluded if they reported alcohol or substance abuse symptoms in the last 6 months, or if they were diagnosed with current comorbid social anxiety disorder. All the participants were fluent in English, they were all free of head trauma, and they were also all paid $25 per hour to participate in the study. The researchers also conducted a rumination induction task. The rumination induction task included 10 statements from each of 3 conditions. The conditions were rumination, which we refer to as RUM, concrete distraction, which we refer to as CON, and abstract distraction, which we refer to as ABS. Prior to this study, most behavioral rumination studies have used CON distraction statements as a control condition, which meant that CON distraction was the control statement and RUM was the experiment statement. However, in order to adapt the rumination versus distraction design to the scanning environment, the researchers needed an additional control condition which would better match conceptually to the rumination statements. Ergo, a second distraction condition, abstract distraction or ABS, was used to permit a contrast that, as compared with the CON statements, would be less visual and less reliant on mental representations of external objects or screens. The researchers also hypothesized that the abstract distraction condition would allow for the isolation of neural activation in a control condition, which is closely related to abstract ruminative thought. So now we are going to look at how the rumination induction task was conducted. So the first thing we'll look at is the instruction. The participants were told to focus, visualize, and concentrate on the idea presented in the statement as it appears in front of them. The statements themselves, 30 statements appeared for 30 seconds and separated by a 10-second fixation cross. After the statements, the participants were then instructed to stop thinking about the previous statement and to clear their minds for the next statement. Now we're going to look at the statement sets. So there were 2 runs of 5 statements for each set in a fixed order to form a block. So we had run 1 and run 2. For run 1, there were RUM statements from 1 to 5, CON statements 1 to 5, and ABS statements 1 to 5. For run 2, we have RUM statements 6 to 10, CON statements 6 to 10, and ABS statements 6 to 10. So they were counterbalanced in terms of the runs that the participants received. So for example, one group would get run statements 1 first, and the second group would get run statements 2 second, and vice versa. So there was like a switch between who would get run 1 then run 2, and those who would get run 2 then run 1. There was also a rating system. So using 10 seconds, they had to rate, the participants had to rate their level of sadness on a 1 to 4 scale using a button box after each block. In terms of imaging analysis, all pre-processing and analyses were conducted using an analysis of functional neural images. Functional neural images were obtained using functional MRI. Okay, now you go to the results. Thank you.
Good afternoon, everyone. I'm Andrea, and today I'm going to present to you the results of the study. So, a two-way ANOVA on repeated conditions was conducted on SATMO ratings. The group consisted of participants with major depressive disorder, or by its abbreviation MDD, and non-depressed control participants, or CTL, while the condition referred to the different tasks that the groups had to complete. In this case, the rumination induction task, the abstract distraction task, and the concrete distraction task. Ratings yielded only significant main effects of group and condition. The group's main effect reflected that greater sadness ratings were reported overall by the major depressive disorder participants, while the condition's main effect reflected greater sadness responses after the completion of the rumination versus the abstract distraction tasks. The interaction of group and condition was also not significant. A similar two-way ANOVA was conducted on reaction times for the mood ratings. Again, the group consisted of participants with major depressive disorder and non-depressed control participants. Conditions were the same, employing the rumination induction task, the concrete distraction task, and the abstract distraction task. Results yielded a significant main effect for group, indicated that major depressive disorder participants were slower to respond overall than were the non-depressed control participants. Neither the main effect for condition nor the interaction of the group and condition was significant. If we look at the table 2 from the paper, we can see that overall, major depressive disorder participants reported higher ratings of sadness. Sadness ratings were also higher in the rumination induction task compared to other conditions. Also, note how major depressive disorder participants took longer to respond to statements in the tasks. Now, let's move on to the imaging results. So, imaging data for both within group and between group analysis are presented for the two primary countries of interest: the rumination versus concrete distraction task, and rumination versus abstract distraction task. We're going to look now at specific imaging results from within group activations on the rumination versus the concrete distraction conditions. Major depressive disorder participants show significant activations were present in the rostral anterior cingulate, the inferior parietal lobe, the insula, the middle frontal and occipital gyri, the precentral gyrus, the precuneus, superior temporal gyrus, and thalamus. The non-depressed control group exhibited activations in the inferior and superior parietal lobes, precuneus, pre- and post-central gyri, the fusiform gyrus, middle occipital gyrus, and the superior frontal gyrus. So now let's look at the between group activation. So the between group activation in the rumination versus concrete distraction condition showed that compared with the major depressive disorder participants, non-depressed control participants exhibited significantly stronger activations in the caudate and visual association regions, including the lingual gyrus, the cuneus, the precuneus, and falciform gyrus. Major depressive disorder participants exhibited greater activations than the non-depressed control participants in the thalamus, middle frontal gyrus, orbital frontal gyrus, and subgenual anterior cingulate. Now let's look at the within group activations. So the within group activations showed that the major depressive disorder participants exhibited significant activations in the rumination induction versus the abstract distraction contrast. Within the dorsal anterior circular cortex in Brodmann areas 32 in the dorsal anterior cingulate cortex, the cuneus, the inferior frontal gyrus, the inferior parietal lobule, the middle frontal gyrus, specifically in Brodmann's area 10 and the medial prefrontal cortex, and finally the middle occipital and temporal gyri. Now, non-depressed control participants exhibited activations in the cuneus and precuneus, and similar to the major depressive disorder participants in the medial frontal gyrus, but in this case in Brodmann's areas 10 in the medial prefrontal cortex, and superior frontal gyrus in Brodmann's area 9. In response to the rumination versus abstract distraction contrast, the between group activation showed that non-depressed control participants had greater activation than the major depressive disorder participants in only the inferior frontal gyrus. In contrast, the major depressive disorder participants had significantly greater activation than the non-depressed control participants in the dorsal anterior cingulate cortex, the rostral anterior cingulate cortex, the inferior parietal lobule, the middle frontal gyrus, the middle occipital gyrus, the parahippocampus, the amygdala, the posterior cingulate cortex, and the middle and superior temporal gyri. After this, thank you for your attention. Now we can move on to the discussion.
Now, here we are with the discussion. This study used fMRI to examine patterns of neural activation as depressed individuals ruminate. Why? Because Rumination involves a number of specific cognitive and affective processes, including self-focused attention, self-referential processing, and recall of autobiographical memories. The hypothesis is participants with major depressive disorder would exhibit increased activation during rumination in regions associated with emotional processing, for example, amygdala. Retrieval of autobiographical memory, for example, parahippocampus, and the processing of self-related concepts, for example, medial prefrontal cortex. In addition to including a distraction condition with concrete statements that have been used in previous behavioral studies of rumination, this study added a novel set of abstract distraction statements that the authors hypothesized would better isolate differential activation due to emotional processing, memory retrieval, and self-focus during rumination. To support this prediction, the two contrasts, which are activations to rumination versus concrete distraction, and activations to rumination versus abstract distraction. These two contrasts highlight different patterns of activation associated with rumination. Within group analysis of the rumination versus concrete contrast, review activations common to both the depressed and control groups. In regions affiliated with higher order visual association and attention, such as the middle occipital gyrus, precuneus, and inferior parietal lobe. Next is the between group analysis of the rumination versus concrete contrast. Indicate greater activation for the control group comparing with the depressed participants in regions associated with the generation of mental imagery, including the cuneus, precuneus, fusiform gyrus, and lingual gyrus. In contrast, depressed participants exhibited greater activation in regions associated with the generation and regulation of mood states. Subgenual anterior cingulate, orbital frontal cortex, thalamus, and dorsolateral prefrontal cortex. Figure 1 is showing you the activations to rumination versus concrete distraction contrast. In yellow, is showing the activations in depressed participants, and for the control participants is in blue. Particular interest is the increased activation observed in the subgenual anterior cingulate cortex, or SGACC, in the rumination versus concrete contrast. In this context of this study, it is possible that the activation in the SGACC reflects autonomic aspects of emotional processing during the ruminating condition as compared with the control condition experience of emotion, including autonomic functioning. Therefore, the SGACC activation observed in depressed individuals may indicate that they are responding to rumination statements with a greater degree of emotion than are the control participants. Although it is very interesting that the rumination condition was associated with greater activation in a prominent region in neural models of depression, for example, SGACC, than was in the control condition. It is not clear that this contrast disambiguates neural differences specific to the cognitive and affective subprocesses that characterize rumination. And this is why the authors developed the second contrast, rumination versus abstract distraction concrete, to access more directly depression-associated differences during rumination as compared with representing more abstract and complex concepts. Consistent with findings of previous investigations of self-focus, findings of previous investigations of self-focus, the within-group analysis of the rumination versus abstract concrete contrast yielded activations in the medial prefrontal cortex, or MPFC, in the area of BA10 in both participants with major depressive disorder and the control participants. Moreover, the between groups comparisons of activations during the rumination versus abstract concrete contrast conditions reveal robust differences in hypothesized regions, with depressed participants exhibiting greater activation than did the control participants in the amygdala, parahippocampus, RACC, MPFC, and posterior cingulate. These data represent the first evidence that the amygdala is indeed differentially active in depressed than in non-depressed individuals during rumination. Figure is showing you the activations to rumination versus abstract distraction contrast. The yellow areas are the activations in depressed participants, and the blue areas are the activations for the control participants. Rostral anterior cingulate cortex, or the RACC, is a subregion of the MPFC. Its activation in this study may reflect increased attention toward one's internal state that is unique to depressed participants. Increased self-focus or attention toward those emotional responses may in turn reinforce the higher level of recruitment of RACC that we observe in the depressed participants. As compared with the controls, depressed participants also exhibited increased activation in the posterior cingulate cortex, or PCC, in the rumination versus abstract distraction contrast. This structure has been highlighted as part of the default mode network, and it is hypothesized to be active during the generation of internal thought and inhibited during various cognitive tasks. The rumination condition used in this study is similar to some resting state conditions used in investigations of the default mode network. Within this network, anterior regions are hypothesized to be associated with self-focused aspects of internal thoughts. Posterior regions, including the PCC, are associated with the retrieval of autobiographical memories. The increased activation within the parahippocampus, also observed in the depressed participants, suggests that during the rumination versus abstract distraction contrast, they are engaging in more mood-congruent memory retrieval. Importantly, control participants also exhibited activation within the PCC during the rumination versus abstract distraction contrast, but they did so to a lesser extent than did the depressed participants. This finding supports recent observations that depressed individuals are characterized by impaired, context-dependent reductions in activation in default mode regions. The final region of activation that we should consider here is the dorsolateral prefrontal cortex, or DLPFC, which is common to both depressed and healthy control participants. The rumination versus concrete distraction contrast identify greater activation in DLPFC in the depressed participants than in the control group. In response to the rumination versus abstract distraction contrast, both the depressed and healthy control participants exhibited activation in different subregions of the DLPFC. The regions are BA46 and BA9, respectively. These findings are consistent with work demonstrating greater activation in DLPFC during self-referential processing in depressed individuals and with the growing literature documenting structural and functional irregularities of the DLPFC in depression. Considering in light of the strong association between rumination and the development and maintenance of depressed mood, the differential pattern of activation observed in DLPFC in the depressed participants as compared with that in the control participants. For example, increased DLPFC activation in the depressed participants during rumination as compared with both the abstract and concrete distraction conditions reinforces the importance of continued investigation of this region. At this early stage, it is not yet clear whether hyperactivation of the DLPFC during rumination in depression reflects an impaired regulatory mechanism or whether the DLPFC may indicate recruitment toward more basic cognitive demands during self-focus. This is an important question for future research to address.
Let's take a look at the limitations for this study. The first limitation is that the researchers use a modified block designed to induce rumination behaviorally. That means in future studies, it will be best if they include other approaches such as event-related designs that would alternate between various conditions or that would vary in the length of presentation of the statements or the duration of the intervening fixation period. The second limitation is that only neutral statements were presented in the study. However, to explore systematical group differences in ruminative self-focus induced by valence material, additional research examining neural functioning in depressed and healthy control individuals in response to positive and negative stimuli is necessary. The third limitation is that the activation observed was due to the state effects of sadness. That is, patients or participants with MDD and control participants differed in baseline mood prior to being scanned, as well as in moods during the scan. Ergo, future work should also examine high versus low rumination depressed individuals to clarify whether the neural profile of depressed individual during ruminative self-focus is unique to this disorder. The third and last limitation is the inferences regarding association between activation and specific subprocesses are necessarily speculative. Now let's move over to the conclusion. The present findings contributed to our understanding of the basis of rumination in depression by elucidating the neural regions that are tonically overactive in depression and those that are activated by specific types of tasks. By investigating the neural basis of rumination as a mechanism by which negative mood is enhanced, we gain insight into the cognitive processes that characterize depressed individuals as well as they ruminate, allowing us to create tasks to interrogate more effectively neural aspects of depression. More importantly, greater understanding of these neural patterns will allow us to refine our ability to diagnose and treat individuals with MDD. Thank you very much for listening.